Ever wondered why User Datagram Protocol or UDP is essential in networking? Well, it's all about efficiency and speed in data transmission, and UDP brings a lot to the table in this regard. When we speak of UDP, we're talking about a computer networking protocol used in the transport layer of the Internet Protocol suite. It's a simple, connectionless protocol that is used to send messages or datagrams over an IP network. But why is this important? Let's dive a bit deeper. UDP is often used in applications where speed is a priority over reliability. This doesn't mean that UDP is unreliable, but rather it's more focused on ensuring low latency and loss-tolerating connections. In other words, it's all about the quick and efficient delivery of data. Think about it this way. You're watching a live stream of a concert. If the data packets were to arrive out of order, or if some were lost along the way, you wouldn't want the video to pause or buffer as the system tries to correct the issue. Instead, you'd probably prefer the video to continue playing, even if there's a minor glitch. UDP makes this possible. The same principle applies to online gaming. Imagine you're in the middle of a heated match. The last thing you want is for your game to freeze because a data packet didn't arrive. With UDP, the game continues, ensuring that your gaming experience remains smooth and uninterrupted. UDP also plays a crucial role in the domain name system, or DNS, which is how your computer translates website names into the IP addresses that it understands. This quick and efficient protocol is perfect for this kind of task, where the rapid exchange of small amounts of data is essential. Another important feature of UDP is its use in multicast systems, where one sender is transmitting data to multiple receivers simultaneously. This is particularly useful in applications like video conferencing or live TV broadcasting over the internet, so it's clear that UDP plays a significant role in making our digital experiences smoother and more efficient. By providing a fast, efficient way to transmit data, it truly is an unsung hero of the digital world. But what exactly is User Datagram Protocol, and how does it work? Let's dive right in and demystify this crucial component of internet communication. User Datagram Protocol, or UDP, is one of the core members of the Internet Protocol suite. Imagine it as the no-frills, get-it-done-quick member of the family. It's often used for time-sensitive transmissions like video streaming or online gaming, where a slight loss of data is acceptable in exchange for speed. The protocol works by sending data packets over the network without establishing a connection. This is known as a connectionless protocol. It's like sending a postcard without a return address. If the postcard gets lost, there's no way to track it back. The sender just keeps sending postcards, hoping they reach their destination. Now, you might wonder why anyone would choose a protocol that doesn't guarantee delivery. But here's the thing, UDP is faster than other protocols because it doesn't bother with the formalities. It doesn't wait for the receiver to confirm receipt before sending the next packet. It just keeps sending data at full speed. This is why UDP is ideal for real-time applications. Think about it. When you're watching a live video or playing an online game, you don't want to experience buffering or lag because a few data packets didn't make it. Instead, you'd rather have the video or game continue with minor imperfections. So, in a nutshell, UDP is a bit like the hare in the classic tale of the hare and the tortoise. It prioritizes speed, darting off without waiting for acknowledgements or dealing with retransmissions. But remember, unlike the tale in the world of internet protocols, there isn't a clear winner. The tortoise-like protocols have their place, and so does our speedy hare, the UDP. Speaking of speed, it's also worth noting that UDP is stateless. This means it doesn't keep track of the session's information, which further contributes to its speed. In essence, UDP is like a fast, no-nonsense courier that delivers your data quickly, even if it means occasionally missing a few bits. You might be wondering, how is UDP different from other protocols like TCP? Well, let's dive right in and explore these differences. Picture this. You're sending a letter to a friend. If you're using TCP or Transmission Control Protocol, it's like sending a registered mail. Your friend needs to sign for it, and you get a receipt confirming that they received it. Now, that's a reliable way of sending information, but it does take a bit more time. On the other hand, UDP, or User Datagram Protocol, is like sending a postcard. You jot down your message, drop it in the mailbox, and hope for the best. There's no confirmation of receipt, but it's quicker because there's no waiting around for a signature. This makes UDP faster than TCP. This lack of acknowledgement in UDP might seem like a disadvantage, but it's actually what makes it ideal for certain applications. Think about it. When you're streaming a video or playing an online game, you want the data to flow continuously and quickly. You don't really care if a few data packets are lost along the way, as long as the overall experience is smooth. That's where UDP shines. It delivers a steady stream of data without the interruptions of TCP's check and confirm approach. UDP also doesn't establish a dedicated connection before transferring data, unlike TCP. This means that UDP can send data to multiple recipients simultaneously, making it perfect for broadcasting and multicasting applications. However, it's important to remember that while UDP might be the faster, more efficient courier, it doesn't have the reliability of TCP. With UDP, there's a chance that the data might not reach its destination or might arrive in the wrong order. But for real-time applications where speed is more important than perfect delivery, UDP is often the protocol of choice. So while TCP is the reliable postman who ensures each letter is delivered, UDP is more like a newspaper boy who quickly delivers without checking. Each has its own strengths and weaknesses, and their usage depends on the specific requirements of the task at hand. Now that we understand what UDP is and how it differs from TCP, where exactly do we use UDP? Well, the beauty of User Datagram Protocol lies in its simplicity and speed, which makes it the protocol of choice for several real-time applications. Let's start with video conferencing. In a live video call, we need fast, uninterrupted transmission of data. Waiting for missing packets to be resent and rearranged would lead to an awkward, choppy conversation. This is where UDP comes in. It sends data packets as quickly as possible, with no time wasted on tracking and arranging them. So even if a few packets go missing, we still get a relatively smooth video call experience. Live broadcasts like your favorite sports events or news channels also rely on UDP. Imagine watching a football game where the transmission keeps pausing to ensure every single data packet is received and arranged correctly. It would ruin the real-time experience. UDP allows the broadcast to flow smoothly, maintaining the thrill of watching the event live. Now let's talk about online multiplayer games. These games require real-time interaction between multiple players. Any delay or interruption can disrupt the gaming experience and may even determine winners and losers. UDP, with its fast data transmission and low latency, is the perfect fit for this. It ensures the game runs smoothly, and player actions are reflected in real time. In these applications, minor data loss is acceptable. A few missing pixels in a video call, a second of fuzziness in a live broadcast, or a slight jerk in an online game doesn't significantly impact the overall experience. What's more important is the speed of data transmission, and that's exactly what UDP delivers. So the next time you're enjoying a smooth video call or an intense gaming session, remember it's UDP working behind the scenes. This simple yet efficient protocol plays a huge role in our digital experiences, often without us even realizing it. Let's take a moment to recap what we've learned about User Datagram Protocol. The User Datagram Protocol, or UDP, is an essential part of the lifeblood that keeps the internet running. It's a transport protocol, a part of the Internet Protocol suite, serving as a middleman between applications on network devices and the network itself. It's lightweight, speedy, and unburdened by the need to establish connections or ensure data delivery. UDP is the go-to protocol for applications that prioritize speed over reliability. It has no time for handshakes or acknowledgements. It just sends the data and moves on. This makes it ideal for real-time applications like video streaming or online gaming, where a few lost data packets are less disruptive than delay. But let's not forget the significant difference between UDP and its more famous cousin, Transmission Control Protocol, or TCP. Unlike TCP, UDP is connectionless, meaning it doesn't require a pre-established connection to send data. This lack of formalities allows UDP to deliver information faster but at the cost of reliability. If data integrity is crucial, TCP is the better choice. But for speed, UDP takes the crown. And let's not undermine the versatility of UDP. It's not just for real-time applications. It's also used in domain name system lookups, simple network management protocol operations, and even in voice-over IP services. It's like the multitasker of the networking world, juggling different roles and applications with ease. So, let's appreciate UDP for what it is, a protocol that prioritizes speed and efficiency, even if it means potentially dropping a few packets along the way. It's a protocol that's not afraid to take risks, to be different, to defy the norms. It's a protocol that understands the value of time and the importance of delivering data as quickly as possible. And that's UDP for you, the unsung hero that keeps our real-time digital experiences running smoothly.